Good morning, students. Welcome back to digital signal processing class. In the previous class, we have discussed the constructions of 8-point DFT from the 4-point DFT. That particular flow chart we have seen. In today's class, we are same topic. We are continuing. We are going to see the fast Fourier transform in it. The second topic in that we are going to see the construction of 8-point DFT from 2-point DFT. How do we construct that one? That we are going to see. So what is actually that particular thing we need to see? In the previous class we have discussed, whenever we want to design the fast Fourier transform, it can be done in two methods. One is decimation in time, second would be decimation in frequency. By doing these two methods, we can able to convert your fast Fourier transform for n points DFT. In that, today we are going to discuss the construction of 8-point DFT from 2 points DFT. So what is the topic of discussion is construction of 8-point DFT from 2-point DFT. That is our today's topic for discussion. So in order to convert this from the 2-point DFT, we need to construct the 8-point DFT. How do we do it? In the previous one, we have taken even number of samples one end and odd number of samples at another end. The same way, we are going to convert that particular sequence, input sequence. We want to write even number one end and odd number another end. We'll take two values for it and we just want to convert it. How do we do it? It required 3 stages. First stages is what? We'll take first 2 even value, another 2 even value. Likewise, we'll take another 2 and another 2 odd values. So in this, what we are taking? We are taking 2-point DFT. This is what? 2-point DFT for first even samples. This is what? Another 2-point DFT for another 2-point samples. This is also another 2-point DFT for odd samples. 2-point DFT for odd samples. So what is the first input we do have? We have first, what is the first even? X of 0. The next is what? X of 4. That means consecutive. If you see the consecutive difference of these two needs to be 4. Whatever the input number will take, input sample value will take, the consecutive difference needs to be 4. For that, what we'll do it? We'll take next one, X of 2. Next even number is X of 2. So if you want to take a difference of 4, then it would be X of 6. So if you see the difference of 2 and 6, it's what? 4. Difference of 4 and 0, again it's what? 4. That is we get from bit reverse order. That is the next topic for our discussion. In that we are going to see how do we convert that number of bits of first sequence into the number of bit of the second sequence. So that is our next topic for discussion. So in this, what we are taking? We are combining 2 inputs. First input for the even number of samples, second also for even number of samples. Likewise, we can take for the next one, what I can take? Next odd. So it is what? X of 1. If you want to take a difference of 4, it would be X of 5. So 5 minus 1 would be 4. So obviously here if you will take 1, 5 is done. Next, what is the next odd number? X of 3. Likewise, I can write it as for X of 7. So 7 minus 3 difference is what? 4. So that's how we have taken first 2 for even, another 2 for even. Likewise, we have taken next 2 for odd. So this way, what you have given? You have given the inputs for this particular 2-point DFT. Totally, if you want to see total combination, how many right now? We are designing for 8 points. That's the reason this complete needs to be 8-point. Upper 4 for the even, then lower 4 for the even. So by taking that all these 4 and 4, we can take this whole thing into the consideration for designing the what? 8-point DFT. So now what we'll do? We'll take the stage 1. In stage 1, what we'll do? We'll try to write the designing, that is butterfly diagram for it. That is nothing but flow graph or butterfly diagram. So in this, what we are taking? We are taking first inputs. So what is the first input we had? X of 0. This is what? X of 4. So likewise next 2, likewise next 2, likewise we'll take next 2. So that first stage. In first stage, 1, 2, 3, 4 dot will put it. 1, 2, 3, 4 dot will put it. We'll cross take it. This input needs to be taken from this end. This input needs to be taken for this end. This is nothing but we are crossing. We just want to go for stage 1 analysis. Likewise, I can combine these two, this one with the next one. So this is nothing but when we are going in the back, that is nothing but feedback. This is called feedback, in which you have to write the next sequence as per that. So what is the input do we have here? We have x of 2, here we do have x of 6. Likewise for the next two. So where should we take the next two? From this end, cross. In this, we'll take this one last with the first and this with this one. So what we got? We got the required stage 1. So in this, the inputs value is what? X of 1, x of 5, x of 3 and x of 7. So this is the bit reverse order. So we have taken that and we have just constructed the stage 1. So in stage 1, suppose I am saying this is nothing but when we are taking this cross, this is nothing but the weighting sequence. So what is the weighting sequence means? We have saw the Twiddle factor, right? Wn of nk. What is Twiddle factor formula we have seen? So W, n number of sample for n domain and k domain can be written as e power minus j 2 pi k n by n. This we have seen. So that Wn of nk, what is that indicates? Number of samples in that particular stage. So how do we taken that number of samples in that stage? We need to write that into feedback. Feedback in the sense, instead of going for the actual cross multiplying, we are taking through like a cross one. So this crossing end, whatever we had, that is called it as feedback path. For the feedback path, we need to mention what is the value for it. So it's a stage 2. So in stage 2, when we are going from stage 1 to stage 2, that is the output stage, we have to write its weighting sequence. Since it is stage 2, when we are going from 1 to 2, we will write even weighting sequence. So since it's how many point sample? It's 8 point sample. So that's the reason we'll mention W8 of 0 here, W8 of 2. Same way we can go for the next part. Here also we'll take the next two. We can write it as W8 of 0 and W8 of 2. Whereas the first indicates the first sample value and the second indicates the second sample value sequence. So wherever we had the feedback, you can see these are the feedback, right? So whenever we are take the feedback of it, for that particular sequence, we need to take the value for that sequence with weighting sequence. So here 0 2, also here also 0 2. So this is what 8 number of samples, so W8 of 0, then W8 of 2. So this is what we have done with the stage 1 analysis of that 8 point DFT. The first stage is done. Likewise, we can proceed with the second stage. In second stage, what we'll do? Here we are combining 2 2. Whereas in the previous one, what we need to combine? We need to combine the 4 4. So how do we combine this one? You'll just see. What is the first output we can write? X of 0. Next output is what? X of 1, X of 2, X of 3, X of 4, X of 5, X of 6 and X of 7. So we do have this one 1, 2, 3 and 4. 5, 6, 7 and 8. So we got this one, right? So for this what we'll do, these 4s are there, we'll start from the end. So that means this needs to be go for this last end. 1, 2, this is 3 and this is your 4. So we combine these all 4 output value with this particular stage 1 values. Likewise for this one what we'll do it, we'll write, we have this one, right? We combine with the first one 1, 2, 3 and 4. So for this, when you want to write the feedback, what we need to write? We need to write the weighting sequence. So what is the weighting sequence we do have? Here 0 and 2, 0 and 2 we have taken. Here since we are taking 4, 4 means 0 to 3. So what we'll write for this? W8 of 0, W8 of 1, W8 of 2, W8 of 3. So we'll write all this weighting sequence for feedback path. These all are what actually? These are nothing but like a feedback path. So this is how you have designed your construction of 8-point discrete Fourier transform from 2-point discrete Fourier transform. This is the exact flow graph or butterfly diagram for designing that particular discrete Fourier transform. So this is the way you can design by 4-point DFT or else by taking the 8-point DFT. So what is the conclusion by doing in these things? What we can conclude this thing part? You can conclude that if you want to write the DFT of 8-point or 4-point, first thing we need to write in bit reverse order. Bit reversal or bit reverse order. What that bit reverse order means? The bit should be reverse. The bit, if you want to write that bit of any number, that could be reverse. Or in general, you remember to solve the problem that the difference of the bit needs to be 4. Like 0 minus 4, it's what? 4. 2 minus 6, it's what? 4. That means initial this 4 value indicates it's nothing but even sample or even sample inputs. The next indicates out sample. So this one odd sample inputs. So we do have even and we do have odd. So both the values we wrote it. Then since they asked to design for 2-point, we have taken 2-point, 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 2-point. Combining in the whole thing is what? It's nothing but like a 4-point. After that we have go for stage 1 analysis. In stage 1 what we have done? We have taken the 2 crossing, in which if you do have a feedback, we have taken weighting sequence, that is Twiddle Factor. We have mentioned 0 and 2. Likewise for the second also we mentioned 0 and 2. After knowing this thing, we reach to the next, that is the output stage, stage 2, in which we need to mention what is the output for that particular sequence, and whenever we do have feedback, for that we have mentioned weighting sequence. And always the feedback should be followed by -1, because whenever we take the values for it, we'll mention -1 for solving. Wherever we wrote weighting sequence, right, those weighting sequence values should be written as -1. So this -1, this -1, this and this. So this will be the butterfly diagram or the flow graph for designing the 4-point DFT. For 4-point DFT, we'll mention it and we will design it. So we'll see the next one about the summary of writing decimation in time and decimation in frequency of FFT. We will see now. So as you have seen, students, just now we have designed the 8-point DFT for by using the 4-point DFT and by using 2-point DFT. Next concept is how do we write that Twiddle Factor. For the Twiddle Factor we do have W n of nk is given by e power minus j 2 pi k n by n. This one we had. If you had 8-point DFT, what we have mentioned for the Twiddle Factor? W8 of 0. Likewise W8 of 1, W8 of 2, W8 of 3. So how do we write these all values? So in order to write this thing, what we required? We required the simplification in this. So if you want to write 0, so e power minus 0 j into 2 pi as it is. What is k value? 0 by n. What is n now? Samples. What is number of sample? It's what? 8. So since it's 0, so it's whole of 0. Similarly, e power minus j 2 pi kn. What is kn value we had here? 1. So into 1 by 8. This is written. Similarly, for writing the next sequence, W8 of 2, how do we mention? E power minus ga 2 pi. What is kn value? 2 by 8. It's in power. Likewise, you want to write for W8 of 3. E power minus j 2 pi of 3 by 8. So we got these all weighting sequence. So now what is the value we can write for this? E power 0. E power minus 0 is nothing but 1. Here I can write e power 2 1s are 2 4s are. So e power minus j pi by 4. Here I can write e power 2 2s are 4, 4 and this will be cancelled, e power minus j pi by 2. Here is what? 2 1s are 2 4s are. So e power minus j 3 pi by 4. So what is e power minus j theta? Cos theta. Cos pi by 4 minus j sin pi by 4. Similarly for cos j pi by 2, what I can write? Cos pi by 2 minus j sin pi by 2 I can write. Likewise I can write for the next minus. So cos 3 pi by 4 minus j sin 3 pi by 4. So what is the value here? Cos pi by 4 is nothing but 1 by root 2. So 1 minus j by root 2. Or in points if you want to write, how do we write? 0.1 by root 2 is what? 0.707 minus j of 0.707. Similarly, cos pi by 2, cos 90 is what? 0. Minus j into sin 90 is what? 1. So answer is minus j. Similarly, for the next one, what is the next value we had? Cos 3 into 45, 135. Cos 135 is what? Minus 1 by root 2. Minus sin 135 is what? 1 by root 2. So in other way, what I can write? Minus 0.707 minus j of 0.707. So what actually, when we want to solve this butterfly diagram, you need to remember these values directly. So if I'll say W8 of 0, that means it's equals to 1. If I'll say W8 of 1, the power of 1 would be 0.707 minus j of 0.707. That you need to remember. So for that, what actually this whole thing is calculated before getting the value for that particular twiddle factor or weighting sequence. Likewise, we do have next W8 of 2 is nothing but minus j. How would you got? Cos 90 minus j sin 90. We did and we found the value of that one. Likewise, we can find for the next one W8 of 3. The weighting sequence of the next would be solved like this, and we got minus 1 by root 2 minus j by root 2, and that is nothing but minus 0.707 minus j of 0.707. So we got these all weighting sequence. When we solve the value, when we had a butterfly diagram for 2 points, for 4 points, for 8 points, we will use these values. So how do we get that one? So in order to get these things, we will solve one problem. We'll just solve this one by taking the weighting sequence and we will find out. So how do we do it? So you see, after knowing this all value, we need to understand if you do have a single graph like this, if you do have a single, I'm taking one butterfly sequence of 2 points. If I am having P sequence with, if I'm taking the P having this mth sequence, if I'm having Q of having n sequence. If I want to find out the value for it, this is what feedback. So what is the feedback value? It's nothing but minus 1. If I'm having a weighting sequence Wn of k, this I do have. So if I want to write the next sequence for this, if I want to write P n plus 1th sequence, next sequence of it, how do I write? If I'm having, this is my, suppose x of 0, this is my x of 1. So how do I write this thing? First, it's there for the first sequence. So what is the first value I'll write? X of 0 plus, since it is going crossly, right? So what is the value here? X of 1 into Wn of k. If I'll get the next value for it. So the positive one, since it's getting this way and we had one more input this way. If this is the next stage. Suppose this is our input for present stage is m, the next stage will be m plus 1. Likewise, if I had n is the present stage, if I want to write the next stage of it, n plus 1, how do I write? Same, I'm getting from x of 0 as it is, but since it's a feedback means it's what? Minus 1. Minus 1 into whatever the number, what is the number here is mentioned? X of 1 into Wnk. So this is the way for simple one. So we have taken only 2 cross and we have written the next stages for it. Pn plus 1 and Qn plus 1, second stage. This is the input stage we had. We need to write the next stage, we have written in this way. So this is also very, very useful to understand the more problem. Just we are learning the basics. We did not start the problem. When they ask the problem, we should understand by taking these values, exponent factor, that is nothing but twiddle factor. By taking this graph analysis also you need to understand. So by taking these two, we will use in the problem. In how many methods to do this FFT? One is the decimation in time, second is decimation in frequency. DIT FFT and DIF FFT. That one we will solve the problems. Before doing this thing, we need to understand one more concept called what is the meaning of bit reverse order and what is the meaning of normal order. Let us see that one. So see here, students, if I am taking n is equals to 8 samples, in that I want to write its bit reverse order. Bit reversal, if I want to write, how do we write that one? So what is this first thing? N is equals to 8 means what is numbers ranging from 0 to 7. So in this, if I am taking the first digit is 0, likewise I am taking normal order digits 1, 2, 3, 4, 5, 6 and 7. If I'm taking these all digits, this is in which index value we are taking. These are our input index we do have. We want to write that index value into binary form. How do we write 0? We will write 0, 0, 0. Since it's what? 2 power 3. 3 inputs we do have. So it's written 3 digits. Similarly, if you want to write 1, 0, 0, 1. 2 would be 0, 1, 0. 3 will be 0, 1, 1. 4 would be 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. 7, 1, 1, 1. This is in normal order, right? We are saying these all are in normal. So this is what actually, this is normal order sequence. So now next thing what we need to write, when you write it's bit reverse. So how do we write bit reverse? So bit reverse you want to write. How do we mention that one? Bit reverse means whatever bits are there you need to reverse that bit. Suppose if you do have LSB bit, that need to be changed into MSB bit. MSB bit needs to be changed into LSB. All bits needs to be rotated. So what is the value? 0, 0, 0. Again you will get 0, 0, 0. So now here 0, 0, 1. So you need to start from LSB bit. From this bit you are reaching to MSB. So how do we write? We'll start from LSB. 1, 0, 0. Likewise, this is your MSB, this is your LSB. If you rotate, what will happen? 0 will come here. Again you will get the same. Now 0, 1, 1. If you change the bits, what will happen? 1, 1, 0. We are changing this bit, right? Next one, if you want to change that one, what will get? 1, 0, 0 will become 0, 0, 1. Likewise, 5 will be same as it is because it won't change. Likewise, I can write for this 1, 1, 0, 0, 1, 1 and 1, 1, 1. Next, I want to write bit reverse index. So how do I mention that one? 0 means again we got 0. This is what? Bit 0. Now tell me, now 1. 1 now it is changing into 1, 0, 0 means it's what? 1 is becoming now, it's what? 4. 2 is becoming again, same 2. 3 is becoming what? 6. 4 plus 2 is what? 6. Now this is what? 0, 0, 1 it's nothing but 1. 1, 0, 1 it's again 5. 0, 1, 1 it's what actually? It's 3. 1, 1, 1 it's what? 7. That's how you have mentioned all the bits in reverse order form. So what is the bit? If you want to write the normal sequence, this is in that form. If you want to write in bit reverse sequence, that should be the form. In other words, what I have explained you, the consecutive bits if you see, the difference needs to be 4. 0 and 4 difference is what? 4. 2 and 6 difference is what? 4. 1 and 5 difference is what? 4. 3 and 7 difference is 4. So that means all bits, whatever bits we are taking, that particular difference we are getting it as 4. So this two type of it, normal order and bit reverse order, it will be useful to solve the problems. That problems we will see in the next class. We will see the summary, how to design the decimation in time and decimation in frequency. So see students, so we do have steps for radix to DIP FFT, and then we had steps for radix to DIF FFT. In that, first of all, we should know fast Fourier transform. To solve this one, we are going for two methods. One is decimation in time, fast Fourier transform, decimation in frequency, fast Fourier transform. So to do these things, we are segregating into two parts. In that, the first thing we are understanding what are the steps V is involved to solve the problems based on DIT FFT. In this, the input samples, the number of input samples, what it decided, that depends upon n is equals to 2 power m. What is 2 power m combination? M is an integer value. If you do have two stages, if they give 4 inputs means how many samples? It's 2 power 2. That means it's 2 samples, 2 stages is required to solve that one. If you do have 8 points, then it is what? 2 power 3, right? That means 0 to 7 bits are required. So if you had 4, that means bits range from 0 to 3. If you do have 8, bits ranging from 0 to 7. As per the number of bits and number of samples given in the question, based upon that we'll take the number of bits. Likewise, we do have next step is the input. when you are solving in DIT FFT, the input should be shuffled through bit reverse order. What is bit reverse order? First 0 will come, then 4. Next is 2, then 6. Difference of each consecutive stage is what? 2. Likewise, we do have 1. 1 with 5. Next is 3. 3 with 7. So these are called what actually? These are called bit reversal or bit reverse order. This is therefore input stage in DIT FFT. And what is the output? Output is in normal order. Normal order means what? 0, 1, 2, 3, 4, 5, 6 and 7. This should be output stage for your DIT FFT. Input should be in bit reverse order, but output is what? Normal order. That is there in DIT FFT. Likewise, number of stages. How many number of stages is required? As we have seen that the complexity of doing the discrete Fourier transform is very high. In order to remove the complexity of such kind of conditions, situations, we are proceeding with fast Fourier transform. So that one, m is equal to log 2 of n. That number of stages are required in DIT FFT algorithm as well as DIF FFT algorithm. That means the complex numbers has been reduced to this much. Then what is this butterfly? That is nothing but whatever the designing we are doing, that is called butterfly. So how many stages is required? n by 2 butterfly stages is required to solve the given problem. Next thing, input output separation. So see, this is your input side, this is the output side. How do they are separated? By what factor? Separated by 2 power m minus 1. What is m indicates? Stages. M is equals to 1 first stage, m is equals to 2 second stage, m is equals to 3 third stage. Depends upon this m value. So based upon this m, input and output are separated by 2 power m minus 1. So complex multiplication of fast Fourier transform is n by 2 log 2 of n. Addition is what? Here we are dividing by 2, here we are not dividing. Directly n log 2 of n. What is Twiddle factor? E power minus j 2 pi kn by n. That way we write. Here we can write Twiddle factor k is equals to nt by 2 power m. So this is for stage steps, or what we call the steps for radix to DIT FFT. For DIF FFT the same thing. Only what is the change in this? This is only the change. We need to look into it. What is the change in that? Input should not be shuffled. Input should be in normal order. Output is in shuffled order. That means for DIF FFT, this has become output and this has become your input. That is quite vice versa for DIF FFT. Remaining all steps are exactly same as you are proceeding with DIT FFT. So this is the way the steps has been designed for your DIT FFT and DIF FFT algorithm. In the next class, we are going to solve the direct problem of your fast Fourier transform for 8-point, 4-point and 2-point FFT. So these steps you need to remember for next class. Make a note of these all points and be ready for problems, and whenever we are explaining the problems, try to practice and try to write that particular problem at that particular time itself. Don't keep and don't take a baggage of writing at the end. Otherwise, numericals you cannot understand what is going on in the class. So thank you for today's class and practice this thing. Have a good day.